We'll solve trigonometric equation, this trigonometric equation, and I will include the solution to the previous video, and we will compare the solution, this solution to the previous solution. So the trigonometric equation here is 8936 to the power of sine squared x plus 8936 to the power of cosine squared x equals 8937. And we will solve for x in radian. Well, we know sine squared x plus cosine squared x is equal to 1. That means sine squared x is equal to 1 minus cosine squared x. So that means this is 8936 to the power of 1 minus cosine squared x. We can substitute this sine squared x by 1 minus cosine squared x, plus 8936 to the power of cosine squared x equals 8937. So that means we can split this into 8936 to the power of 1 times 8936 to the power of minus cosine squared x plus 8936 to the power of cosine squared x equals 8937. Now let's introduce a new variable z, and z is equal to 8936 to the power of cosine squared x. So that means this is 8936, and this is z to the minus 1 plus z equals 8937. So this is then it is 8000. Let's multiply both sides by z. Then this is 8936 times z to the minus 1 plus z all times z equals 8937 times z. Then this is 8936 times z to the minus 1 times z is z to the 0. Z to the 0 is 1. That means this is just 8936. Then z times z is z squared. Then 8937 times z is 8937 z. Then this is equal z squared equals 8937 z plus 8936 equals 0. Then this can be factored as d minus 1 times z minus 8936 equal to 0. That means z minus 1 equal to 0. That makes z equals 1. Or z minus 8936 equal to 0. That means z equals 8936. Okay, so for z equals 1, that means 8936 to the power of cosine squared x equal to z. But z is 1, that means 8936 to the power of cosine squared x is equal to 1. But we know also 8936 to the power of 0 is equal to 1. That means cosine squared x is equal to 0. That means cosine x is equal to 0. That means x is cosine inverse of 0. That is the first solution. And that solution is x equals cosine inverse of 0 is could be pi over 2, 3 pi over 2, 5 pi over 2, minus pi over 2, minus 3 pi over 2, minus 5 pi over 2. So it is basically pi over 2 and it is coterminals, and 3 pi over 2 and it is coterminals. So it can be written as x equals pi over 2 times 1 plus 2n. Where n is any integer from negative infinity to infinity. Then for z equals 8936, so 8936 to the power of cosine squared x is equal to z, but z is equal to 8936. That means 8936 to the power of cosine squared x is equal to 8936, and we know this is equal to 8936 to the power of 1. That means cosine squared x is equal to 1. So that means cosine x is equal to plus or minus 1. Then when cosine x is equal to 1, x is equal to cosine inverse of 1. This is the second solution. And for that, x equals to cosine inverse of 1 is equal to 0, 2 pi, 4 pi, 6 pi, minus 2 pi, minus 4 pi, minus 6 pi. That is x equals 2 pi n, where n is any integer from negative infinity to infinity. When n is 0, it is 0. When n is 1, it is 2 pi. When n is 2, it is 4 pi, and so on. When n is minus 1, it is minus 2 pi, and so on. So that's the second solution. When cosine x equals minus 1, then x is cosine inverse of minus 1, and that is x equals cosine inverse of minus 1 is pi, 3 pi, 5 pi, minus pi, minus 3 pi, minus 5 pi. So it is all, the solution is pi, and it is coterminals, and it can be written as x equals pi times 1 plus 2n, where n is any integer from negative infinity to infinity. Therefore, the three solutions are x equals pi over 2 and all its coterminals, and 3 pi over 2 and all its coterminals. Then x equals 0 and 2 pi and all their coterminals. And the x equals pi and all its coterminals. So they can be written then x equals pi over 2 times 1 plus 2n. So this is when n is 0, it is pi over 2. When n is 1, it is 3 pi over 2, and so on. And x equals 2 pi n. When n is 0, it is 0. When n is 1, is 2 pi, 4 pi, and so on. Or x equals pi times 1 plus 2n. When n is 0, it is pi. When n is 1, it is 3 pi, and so on. So in picture format, in graphic format, then it is, the solution is, number 1, it is x equals pi over 2, 1 plus 2n pi, n 2n, where it is pi over 2 and 3 pi over 2. When n is 0, it is pi over 2. When n is 1, it is 3 pi over 2. When n is 1, when n is 2, it is 5 pi over 2. When n is 3, it is 7 pi over 2. And it fluctuates between pi over 2 and 3 pi over 2. And it is x equals 2 pi n. When n is 0, it is 0. When n is 1, it is 2 pi, and so on. And it is x equals pi times 1 plus 2n. When n is 0, it is pi. When n is 1, it is 3 pi, and so on. So now I will include the previous video, and we'll compare the two solutions. Solve trigonometric equation. We'll solve this trigonometric equation. 4 to the power of sine squared theta plus 4 to the power of cosine squared theta equals 5. We're going to solve for theta in degree. So we know that sine squared theta plus cosine squared theta is equal to 1. That means cosine squared theta equals 1 minus sine squared theta. That means we can substitute this cosine squared theta by 1 minus sine squared theta. then this becomes 4 to the power of sine squared theta plus 4 to the power of 1 minus sine squared theta equals 5. So that means we can split this one into 4 to the 1 times 4 to the minus sine squared theta. Then this is equal to 4 to the power of sine squared theta plus 4 to the 1 times 4 to the minus sine squared theta equals 5. Now let's introduce a new variable z, and z is equal to 4 to the sine squared theta. We'll call that, okay? So that means 4 to the power of sine squared theta is z. Then this is 4 times z to the minus 1 equals 5. Now let's multiply both sides by z. Then this becomes z plus 4 times z to the minus 1 all to the times z equals 5z. Then this is z squared plus 4 equals 5z. Then this is z squared minus 5z plus 4 equals 0. This can be factored into z times z minus 1 times z minus 4 equals 0. That means z minus 1 equals 0. That gives z equals 1. And z minus 4 equals to 0. Z equals 4. Now for z equals 1, 4 to the sine squared theta equals z. That means 4 to the sine squared theta is equal to 1, and 1 is 4 to the 0. That means sine squared theta is equal to 0. That means sine theta is equal to 0. That means theta is sine inverse of 0. This is the first solution. Okay? And this, as we know, theta equals sine inverse of 0 is equal to 0 degree, 180 degrees, 360 minus 180 minus 360. It is all the coterminals of 0 and 180. Okay, so that means this is theta is equal to 180 times n, where n is any integer from negative infinity to infinity. That is, it is coterminals of 0 and coterminals of 180. Then for z equals 4, 4 to the sine squared theta is equal to z. That is 4 to the power of sine squared theta is equal to 4. And 4 is equal to 4 to the 1. That means sine squared theta is equal to 1. That means sine theta is equal to plus or minus 1. So that means when sine theta is equal to 1, theta is sine inverse of 1, which is this is the second solution. And for this we know that sine theta is sine inverse of 1. It is 90 degree, and all it is coterminals 450, 810 minus 270 minus 630, all the coterminals. Well, so this is theta equals 90 degree plus 360 degree times n, where n is any integer from negative infinity to infinity. Then when theta is equal to minus 1, the sine theta is equal to -1. Theta is sine inverse of -1, and this is the third solution. And this is theta equals sine inverse of -1 is 270, and all it is coterminals: 630, 990, -90, -450. So it is theta equals 270 degree plus 360 degree times n, that is 270, plus it is all coterminals. Therefore, the three solutions is: one is the quadrantal angle theta equals 180 degree times n, and the two is the quadrantal angle 90 degree, and it is all coterminals. The third one is the quadrantal angle 270 degree plus it is all coterminals. So it is theta equals 180 degree times n plus theta equals, if we factor out 90 degree, is 90 degree times 1 plus 4n, and theta equals 90 degree times 3 plus 4n. And this is in picture format. So it is, the first solution is theta equals 180 degree times n. It is the coterminals, all coterminals, 0 and 180, and all it is they are coterminals. And the second one is 90 degree times 1 plus 4n. It is a 90 degree, and it is all coterminals. And it is 270 degree, and all it is coterminals, which is 90 degree times 3 plus 4n, where n is from negative infinity to infinity, any integer. And thank you. Okay, by comparing the result of this video and the previous video, in this video we used 8936 and 8937. In the previous video we used 4 and 5. In this video we solve for x in radians. In this video we solve for theta. In the previous video we solved for theta in degree. In this video we used sine squared x equals 1 minus cosine squared x, and we used cosine squared x to solve the problem. In the previous we used cosine squared x equals 1 minus sine squared x, and we used sine squared theta to solve the problem. Okay, so now here in this solution, the first solution is x equals pi over 1 plus 2n, which is the pi over 2 and 3 pi over 2, and they are coterminals. In the previous, the solution number 1 was theta equals 180 degree n, which was the coterminal of 0 and 180. In this video, number 2 was x equals 2 pi n, which is the coterminal of 0, 360, and so on. In the previous, theta was 90 degree times 1 plus 4n, which is 90 degree, and it is coterminals. Number 3, in this video, x equals pi times 1 plus 2n, which is pi, which is 180 degree, and it is coterminals. In the previous video it was 270 degree, and it is coterminals. So the moral of the story is, no matter what numbers we use, how we solve it, degree or radian, how we approach is sine squared x equals 1 minus cosine squared x, or cosine squared theta equals 1 minus sine squared theta. So those all do not matter. At the end, all these problems, they are the solution of the quadrantal angles. The quadrantal angles are 0, pi over 2, pi, and 3 pi over 2, and they are coterminal. That is 0, 90 degree, 180 degree, and 270 degree, and they are coterminal. Coterminal means add to each of them 360 degree. So it is the coterminal, for example, of 90 degree is 90 plus 360 plus 360. You keep adding 316 or keep subtracting 360. Those are what are the coterminals. So the solution is always are the quadrantal angle of the solution of the quadrantal angle, which are 0, 1, and minus 1. So they are cosine inverse of 0, cosine inverse of 1, cosine inverse of minus 1, or sine inverse of 0, sine inverse of 1, sine inverse of minus 1. They are always 0, 1, and minus 1. Please subscribe, share, and like, and ask your friends to subscribe, share, and like.